Okay, this is Emilie Ferreira, and I'm doing test 8. Alright, so for number 1, the rate of change of current is 1.5 minus 0.2 over 3. So that becomes 4.33, and then when you plug that back in to the rate of change, or the magnitude of EMF, which is the derivative of di in respect to dt in respect to time, it's 9e negative 3 times 4.33, which is 39. Okay, number 2. Number 2, the area of the cross-section is pi d squared over 4. So pi, the d is that, or 4 equals 60 centimeters, which is the length. You plug that back into this equation. Oh, that's there, and then it's 1.92. Number 3, the equation for a charged particle is that, and then you plug it into, you plug your numbers. Okay. You plug your numbers into that, blah, blah, blah. Solve for t, your ln, e, ln both sides to get t equals 0.052. And then for b, you do the exact same thing, and you plug in you plug in your other numbers that you were given. It's 1.73. Okay. Okay, number 4. Okay, the equation for resistance is EMF over current, so you plug in your variables, and my variables came out to 65.26 ohms. And then once you do that, you plug it into the length equation, which is length times time times resistance, or torque times resistance, which is 33.3. Alright, number 5. Maximum charge equals CV. Plug it in, you get 51.9. And then you plug it into your omega, and it's 1 over root LC. Which, plugging in all your things, you get 79,056.9 radians per second. And then you plug that into your Imax equation, your current, which is times charge times omega, which plug in your blah blah blah, you get 0.52 A. And number 6. F equals 1 over 2 pi root LC. Change it on for C, you get that. And then you plug in your variables, and it comes out to 503. And those are my variables. I don't know if you need to know them. Whatever. Alright, number 7. Derivative of current in respect to time is negative EMF times length over mu times number of turns times A. Forget what that is. Anyway, and you're finding, because you get that from your EMF equation, which is negative L times di over dt. So that's how you get that. And then plugging in your equations, I didn't write the numbers, but that's what mine came out to be, because I didn't feel like plugging in all the numbers. But yeah. Alright, so 8, magnetic field inside a solenoid is that equation. And my numbers came out to 0.85. And these are my numbers: 425 turns, 15 millimeter diameter, 12 centimeter length, 4.15. The current is 1.5. And for B, use your flux equation, which is E times A, and that came out to 3.26, E negative 9. And for C, the inductance is number of turns times IB over L. Let's say L, I forget. Or times over current, sorry. And that came out to 0.334. And then D, would change because the only thing that would stay the same would be the inductance. Alright, number 9. Derivative of current in effect time is EMF over length, 100 over 19, which is 5.26. B, the same thing, but now it's times e to the negative tr over L. And so the time, it's at a time of 2.5, so you plug in your 2.5 and you get 2.224. And then finally 10, time constant is L over R. Plug in your numbers, you get 8.82. Yeah, so, okay, again, Emilie Ferreira Test 8.